Welcome to the class of medical physics. In this lecture, we are going to discuss about the safety precautions and the safety measures one should consider about while using any electrical device or specifically with the whenever playing with the biomedical instruments. So what are the basic parts? First of all, we look into them. First is AC wiring basics. What one must know what are mean by the wiring, what are their technical ways to treat them, to handle them in order to be more safe, more on safe side, right? So as you all know that AC stands for the alternating current, and AC is a type of electricity used for home appliances in any commercial or industrial level. This is um, one basic thing which is being used by everyday life in every electrical item to run each and every appliances, right? So the transformer in your neighborhoods basically transform power voltages of around 120 volts. This is only for the commercial level, right? For industrial level, for instance, the power supply and the voltages used by the industries have are very much more than this. So the precautions are obviously for all of them, but at this level, while treating with the biomedical devices, the devices have been operated. All medical devices are basically operated at the line voltage, which is of 120 volts, or and not more than the 240 volts, right? So the safety precautions are related to all that commercial level devices and appliances. So when you multiply this voltage by current, it produces the watt, which is basically the power one device uses. This is important because a simple circuit breaker can only stand so much power and is designed to trip if overloaded with power. We all know that we have so many safety devices like the circuit breaker, fuses, and few more, which are specifically designed for this purpose to break down the voltage once we have overloaded supply of voltage from the power station. So even after that, if the voltage is supplied voltage, the voltage coming to your device is not that much enough to break the circuit breaker, to trip off the circuit breaker, but it is that much to be controlled by, or if you just exposed to that voltage, what happens to that and how you have to take care in that case. The question is this. So a continuous electrical circuit consists of basically three types of wires: a hot wire, a neutral wire, and a ground wire. The electricity will flow through the hot wire into the device you wish to empower. The main supply line is your hot wire. However, the electricity then flows back through the neutral wire to complete the circuit. We all know that in order to make the current flow, the circuit must have a closed path. Once a circuit have a closed circuitry, a closed path to flow the current, only then the um circuit will have the power to flow the current, right? So the other wire which is responsible to flow back the current is your neutral wire. Other than that, the ground wire is there to remove any extra power. Again, this is another safety measure which sends a signal back to the breaker, stopping the main power source. Here are some color codings as per the states and country wise, what and where they are used according to the color conventions. Like for example, you have different countries, US, Canada, UK have different color conventions. China, Russia have other than that. Australia, New Zealand, Japan, and South and Asian subcontinents have different sign conventions. So One thing is common is that they do all have common type of supplies. Phase supply, basically, they have three phase supply with different color conventions. They have a common supply, now of course a ground wire, and one phase also. So, as per the continent and where which state or part of the world the device is designed for, they have their own sign conventions, right? Okay. For next is your electrical outlets and further details regarding the wiring connections. First is electrical outlets, AC power plugs and sockets. What are they? AC power plugs and sockets connect electrical equipment to AC power supply in buildings and at other sites. Electrical plugs and socket differ from one another in terms of the voltage supplied and the current ratings, and then the shape, the diameter of the wire, and the connector type where they are connecting, and to which device or to which appliance they are providing the electrical supply. It depends. These factors depends on that. So different standard systems of plugs and sockets are used around the world. Hot, the black wire is the hot wire in our convention, which provides a 120 volts AC current source, whereas neutral is have the color coding of white color, which is called a neutral wire. It provides a return path to complete the circuit, right? For the current provided by the hot wire, the neutral wire is connected to an earth ground. This is a pictorial diagram of a socket where we have three plug connections, one of for the hot wire, one is for the neutral, and one is for the ground wire. Ground wire is responsible to ground any excess power supply coming to the device so that your device can be safe and do not expose to burn or any other damages. The bare wire is called the ground wire. Like the neutral wire, the ground wire is also connected to an earth ground. However, the neutral and ground wires serve two distinct purposes. The neutral wire forms a part of the live circuit along with the hot wire. In contrast, the ground wire is connected to any metal parts in any appliance such as microwave, oven, or coffee pot. This is a safety feature in case the hot or neutral wires somehow come in contact with the metal parts. So this is one extra, you could say, a pathway when a device comes in contact with some metal part, the wire is comes in contact with the metal part. This extra pathway does eliminate the shock of any hazardous event by grounding all that extra coming voltage through this level to the ground. The neutral wire serves as a return path for electrical current, while the ground wire provides a path to the path for electrical current to the earth. Since electricity flows from source to destination and back, each wire serves a specific need to ensure the loop is maintained. Here is overall a general pictorial representation of home circuitry. Like if you start from left top corner, you could see that it is 120 volts root mean square value of the voltage with 60 hertz of the line frequency, and this is specifically indicating the US standards. Like so the supply is coming to the home circuitry through a transformer, and then you can see you have a neutral wire along with the hot wires, which is responsible to supply the line voltage to the home circuitry. Then these three wires are housing two high voltage level, the hot wires, and a neutral return wire, which is tied to the ground at multiple location. So rest is the home circuitry. You could see where these connections are being providing at different wall sockets. you can see. And there is a main breaker as well. The purpose of breaker is again to break down the supply, to stop the supply in case any high voltage is coming into the high voltage is coming in, crossing this main beaker part. So this is all. Next is pervasiveness of electricity and of electric shocks. What could be the possible consequences of an electric shock on the body if somehow anybody could get affect or exposed directly to that electric voltages? The human body is basically a good conductor of electricity. This means an electric current can easily travel through it, because human body, we all know that, is composed of constitute around 70% of the water level. That could be in the form of different liquids present inside the body: your extracellular matrix, your intracellular matrix, your and at different level you have the constituent amount of 70% of the water present in the human body. So water is a good conductor of electricity, obviously. That becomes, or that makes a human body a good conductor though. When current travels through someone's body accidentally, this is known as electric shock or electrocution. You can see what consequences could be in result of electric shock. That could be minor ones or the major ones. Like that could result in, if we talk about the acute and chronic problems, that could result in vision problems, swollen tongue may obstruct airways. So that could may may cause difficulty in breathing. The main effect of electrocution is the irregular heartbeat, or the cardiac arrest, because we all know that human heart works through electrical supply provided by the pacemakers, the naturally occurring pacemakers of the heart. So if someone exposed to the electricity, that easily can disturbs the arrhythmia of the human heart. That could easily disturbs basically the electrical supply of the human body, right? Electrical supply to the heart. That could result in paralysis. The superficial damages can have the burns effect, or irritable loss of consciousness possible in convulsions, difficulty in breathing, respiratory arrest we have discussed. Then that could also result in fractured bone and muscle tenderness, or any possible twitching type. This is also one representation of the conduction of electrical current through the human body. Like, for example, it is showing the grounded contact in one foot. For instance, if you are barefoot with the contact, we all know that current easily grounded into the earth. So if, for example, this picture is indicating that current is entering from a bare wire into the human body, and due to the barefoot, it is having, the current is having a closed pathway to flow the current. That makes the current easily, very much more easy for the current to flow through the human body. So live wire contact in one hand with a barefoot makes a perfect pathway for electric current to flow through the human body. So electrically flows all possible paths. A greater flow of electric current will flow in the path of least resistance. So one must not one must not be go with direct contact to the ground barefoot whenever they are using or treating any electrical appliance directly. They must have shoes in their foot. Next is what makes a shock and what causes a shock onto the heart. in terms of like cardiac arrest. What will be the results? If a current of 50 milliampere passes through the heart, it can cause cardiac arrest. These are the possibilities. The heart is also a muscle because which beats to pump blood through the body. The rhythm of our heartbeat is controlled by electrical impulses. It is these impulses that are monitored by electrocardiogram. If a current from outside the body passes through the heart, it can mask these impulses and disturb the heart rhythms. So, this irregular heartbeat is called arrhythmia and can even manifest as a total disorganization of the rhythm, also known as ventricular fibrillation. When ventricular fibrillation occurs, the heart stops pumping and the blood stops circulating. The victim rapidly loses consciousness in this result and dies and could die if healthy heartbeat is not restored immediately using a device known as defibrillator. The arrhythmia can occur at the time of the shock or in hours following by the electric shock. So that could range, the lifespan could range from few seconds to several hours after the arrhythmia. A shock can cause burn to tissues and organs. When a current above 100 milliamperes, such high current, passes through the body, it leaves marks at the points of contact with the skin. And current high above 100,000 milliampere, sorry, 10,000 milliampere, that is 10 ampere, causes serious burns that may require amputation of the affected limb, because some serious burns are easy to recognize because they look like the burns you can get from contact with the heat. Other may seem harmless, but they are not. Tiny craters indicate the presence of much more serious internal burns, for instance. Electrical burns often affect internal organs. They are caused by heat generated from the body resistant to the current passing through it. Internal damage may be much more serious than the external injury suggested, whereas internal burns often have serious consequences like scarring, amputations, loss of function, loss of sensations, feeling, or even death. For example, if a lot of tissue is destroyed, the large amount of waste generated can cause serious kidney or blood circulation disorders. This is all up to this lecture. Regarding the other serious injuries that could happen due to electric shocks and the safety precautions or measures, we will continue and discuss in the next lecture. So, hope to see you in the next lecture. Thank you.